welcome to another episode of Good Morning Science, the home edition. My name is Dr. Alon Eisenstein and I'm with Pueblo Science. I will be the host for today, and once again we have Bipasha co-hosting with me and we'll share one of the 3 experiments for today. If you are listening or watching our videos for the very first time, welcome for joining. You can always watch all previously recorded episodes on our Facebook page and our YouTube channel, but be sure to subscribe and like the page and channel so you can get notified as soon as we upload a new episode. If you are a returning viewer, welcome back. It's great to have you once again with us for this week. And so, before we get started, I would like to just give you a quick introduction about Pueblo Science if you've never heard this introduction before. If you have, feel free to skip it. It only takes a few seconds, but if you are curious, here it is. Pueblo Science is a charity based in Toronto, Canada, and we go to rural communities around the world, focusing on developing countries and offering professional development training for science teachers in these locations. We believe that by doing so, we can increase the quality of science education around the world and thereby creating a better world for everyone and leaving no one behind. If you think that what we do is important and believe in our cause, please do consider donation, and you can find the donate button on our Facebook page as well as our homepage. And if you'd like to learn more about what we do, please do visit our homepage. We have lots of activities and things we can share with you. Let's move on for today's experiments. I'm just gonna skip to the slide that has the experiments for today, and you will see all the lists. So bear with me and make sure to pause the video so you can go grab the materials if you haven't gotten them already, and then we can begin. So let's go. Back. I hope you grabbed all the materials and you're ready to go to action. And now we're going to move over to Bipasha, who will have our first experiment of the day. I hear that she's got some lemon juice, baking soda, food coloring, and detergent. Are you cleaning or making a mess? Bipasha, going over to you.
Hi everyone, it's good to see you again. And today I have a volcanic experiment for you, if you may call it that. And as usual, we have a little bit of food involved in the form of some lemon juice. You could use actual lemons, which I'll explain an alternative to this experiment towards the end. And we have some baking soda. So we're gonna, some of you might know what's going on, but we're gonna make some cool eruptions and explosive in action with the help of our materials, which are, so we have a glass, we've got some lemon juice, we've got baking soda, dish soap, and some food coloring, and some spoons. So what we're going to do is we're going to first take our baking soda. Oops, little spillage there. About a teaspoon. Just gonna pour it in. Then we're gonna take some dish soap. I'm gonna just add it. Then we're going to take some food coloring. I'm going to take some blue, two drops, and I'm going to take some red. Okay. Then I'm just going to slightly mix it together, just collect all the soap. Sorry about all the clinking noises. Once we've we've got some of that. Then I'm going to pour my lemon juice in here. Let's see what happens. Continue pouring it. And I'm going to add a little bit of yellow just for fun. Did you guys see that? Did you guys see the bubbles and the fizzing sound and the kind of explosion? Let's add some food coloring. And let's add, oh, there's some motorcycles in the background. Let's add some more lemon juice. Let's take our spoon and let's see what happens if we stir it around. Okay, so stirring didn't do that much. I think most of the reaction that we wanted already happened. But look at that, just from some, it doesn't look very appetizing, but just from some baking soda and some lemon and some dish soap, we created this fizzy reaction and all these bubbles, and it kind of smells nice. It smells like a mix of dishwashing liquid and lemon, as you might imagine. And now for the science. So lemon is acidic. You might know that. So the specific acid that we're talking about in lemon is citric acid, and baking soda or sodium bicarbonate is basic. So this is a simple acid-base reaction. So what happens when we mix an acid with a base, it forms a salt and it forms another gaseous product which we're more interested in. And this gaseous product is carbon dioxide. So the carbon dioxide is responsible for all the bubbles. So as you might notice, the level of bubbles kind of reduced. That's because they popped and they disappeared into the air. But the bubbles were because of the carbon dioxide that forms. Now, the dishwashing liquid isn't essential to this reaction. It's more so there to kind of continue to form bubbles and create some like a frothy, cool explosion. And the food coloring is also completely optional. It's just if you want a little bit of color in your experiment. But that's the basis of the experiment. This reaction occurs because of the carbon dioxide that forms. Now, if you want to do something even cooler, what you can do is you can take a lemon, an entire lemon, and with the help of adult supervision, you can cut the lemon from the top and the bottom such that the lemon can sit stably. Then you hollow out the lemon, you take its, you like mush up all the lemony goodness and you create like a lemony juice inside, and you perform the same steps. You add dishwashing liquid, you add some food coloring, and you add some baking powder. And then if you wish, you can pour some lemon juice on top of the solution and you'll see the same frothy, fizzing, like bubbly reaction happening, so much so that it even forms like a lemon volcano with all that goodness just coming out. I went a more simple route. Ooh, it doesn't look good at all anymore. Like it's kind of black because of all the red and blue that we used, and the carbon dioxide has just completely popped away. The bubbles have popped and disappeared into the atmosphere. But yes, if you want something cooler, if you want like a lemon volcano, go ahead, try that. The essence of the experiment, however, is completely the same. So yeah, I hope you guys enjoyed this one too. I hope you try your hands on the lemon volcano, maybe get a little bit creative, maybe try some other fruits as well, some other citrus fruits like limes, oranges, or grapefruits, and let us know if you get the same results at all. I hope you guys enjoyed the experiment, and now I'll give it back to Alon, who has some more fun experiments in store for you. So see you soon. Bye.
Thanks, Bipasha. That was great. And that looked a bit cleaner than I expected. So well done on that. So I'm going to move on to the second experiment, and you'll notice I'm using some of the same ingredients. So it just goes to show how much fun activities you can do with so little ingredients that you probably already have at home, or you just need to stock up on very few items to do so many interesting experiments. So what are we going to do? Well, like Bipasha, I've got my baking soda package with me. I've got vinegar instead of lemon juice. I'm going to use vinegar, and I'm going to take a little jar here, and I've got spoon to grab the baking soda, and I also have candles. You might have noticed that I really like using candles in my experiment. So here are my candles and matches, of course. Okay, so what we're gonna do here? Let me move this closer so you can see what's happening. Ready? Okay. So first of all, I'm going to measure a spoonful of baking soda. So this is gonna be a nice heaping spoon of baking soda. There we go. Put it to the side. Now I'm going to add vinegar. Right. So here's my white vinegar. Now, if you remember from Bipasha's experiment, vinegar is an acid. It's acetic acid, not citric. That is found in lemon. Vinegar is acetic acid, and we're going to add that to the baking soda. Now, if you paid attention to Bipasha's experiment, you know what happens when you mix an acid, specifically to a baking soda, which is a sodium bicarbonate. It's a very specific base. Not every base will do this, but sodium bicarbonate and vinegar. So I'm just going to add it a bit at a time because I don't want it to be overflowing. So you can already see how it's fizzing, 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 fizzing. Oh. Okay. Now if you remember, we've seen from Bipasha's experiment that all this fizzing is releasing carbon dioxide. Now, if you've learned anything about fire, and by the way, this is a great time to get an adult to watch what you're doing because we don't want to start a fire, but we're going to light up a candle and see what happens when I put it into the jar. Ready? 1, 2, 3. Oh, it died. Let's try this again. I'm going to light up my candle. And I'm going to start putting it into the jar. 1, 2, 3, gone. Now what's happening? Well, if you remember from Bipasha's experiment, vinegar, like lemon juice, is an acid, and when it reacts with sodium bicarbonate, which is a base, the specific reaction with sodium bicarbonate creates carbon dioxide. Now, carbon dioxide is naturally occurring in the atmosphere. It's at 0.03%, which means that if you inhale 10,000 molecules of air, 3 of them will be carbon dioxide on average. Only 3 out of 10,000 molecules of air will be carbon dioxide when you inhale. And when you exhale, of course, you're going to exhale carbon dioxide from your lungs as you breathe, right? That's part of our respiration. Now, if you've learned the rule of fire, fire needs 3 things to survive. It needs a source of heat, it needs fuel, and it needs oxygen. In the absence of fuel, heat, or oxygen, fire dies very quickly. Now, because we mixed vinegar and baking soda in this jar, what happens is that we've actually accumulated carbon dioxide in this jar. As it was created in the chemical reaction, it was pushing the air out. So all the nitrogen and all the oxygen that makes up the majority of air has been pushed out, and only carbon dioxide has remained. Now let's see, if I haven't moved the jar, it should still be nicely filled with carbon dioxide, and we can tell by trying to pull the candle inside. Now you can see I can go further down, which means that carbon dioxide has actually escaped. If I try to go even lower, and I think we found the level of carbon dioxide. It's about here. This is now getting very close. So let me just put my candle to the side. Here, I'm just going to light up my tea candle. And I'm going to add some more vinegar because I think I still have some baking soda there. Oh yeah, I do. So I'm going to make some more carbon dioxide. And again, all the carbon dioxide fizzing from the vinegar and the baking soda is pushing the air out and leaving carbon dioxide in. Now, if I use, here I'm going to move this gently. Now, if I put these tea candles side by side, let's see what happens. This one doesn't light up, so I'm just going to move it to the side. But what's happening, if I gently pour, and I don't want to pour the vinegar that's floating around here. I want to just pour from the very top. And look what's happening. Whoop. You see what happened? The carbon dioxide, which is actually heavier than air, pours out. And we can't see it. It's like an invisible fire extinguisher. Isn't it amazing? It's just invisible vapor flowing into the table, onto the table, and smothering the candles. Let's do this again. Ready? I'm just going to do it one more time because it's so cool to see it. Because it's like this magic liquid. We can't see it. It's invisible. Yet you can see how it starts to pour and how slowly and slowly they flicker, and they are gone. I don't know about you, but this is really exciting. This is really exciting. Okay, so that was a really fun thing to do with baking soda and vinegar and candles. I can just do this forever. I hope you enjoyed this one. Let me just clear up this mess and we'll be right back to experiment number 3 of the day. We'll be right back. Okay, time for the last experiment of the week. Experiment number 3 only needs a glass of, or a drinking glass, some water, white paper, and, where did I put it? Markers. So here what we're going to do. I'm going to take a marker. Let's do, there we go, red or pinkish, I guess. Okay, I'm going to draw with my marker. I'm going to draw. I just need one piece of paper right now. I'm going to fold my paper in half. There we go. Just so it doesn't take up too much space. And I'm going to draw 2 arrows. Okay, so I'm going to draw 2 arrows. One here. Okay, there we go. 1 arrow. And I'm going to draw another arrow exactly like it, just above it. There we go. Pointing in the same direction. Okay. Of course, the color doesn't matter, but we want two arrows that are pointing in the same direction. Now, if I'm going to put it behind the glass, you can clearly see behind the glass, where is it? There we go. You can clearly see behind the glass my 2 arrows, right? Okay. Now, I'm going to hold on tight to my piece of paper so it doesn't move, and I'm going to start pouring water in. Ready? And I'm gently pouring water, filling up my glass. Oop, and I only want to reach one of the arrows. Are you seeing what I'm seeing? Check this out. Isn't it cool? What happened? Now I've got 1 arrow pointing this way. Sorry, pointing this way. And the bottom arrow is pointing the other way. So the bottom arrow flipped from going this direction. Sorry, going from this direction, flipped to going into this direction. if I'm going to lift and raise my paper, you see that it's still pointing in the same direction. Both of them are. But if one of them is viewed from behind the glass of water, you can start seeing an effect. Now, why is this happening? Well, this is happening because of the glass filled with water, and water has a property called refraction. Now, refraction is when light passes from one medium, like air, through another medium, in this case water. If the refraction index, or the way the light travels through these two, is the same, usually we use the speed of light as the measure of how similar it is, the effect of light in that medium. If it travels the same way, it goes straight in and straight out. But if the refraction index is different, then light bends. Now, because it bends twice. It bends as it enters, and it bends as it leaves at the back. And the curvature of the glass adds this funky phenomena of making it like a lens. So now this is acting like a lens. It can magnify, right? So you can see how one arrow looks bigger. So it's magnifying the arrow, but it's also flipping it because of the light going through the glass into the water, and there's a curvature. It bends it in a certain way, and going in and going out and back again, and that's how we get the flipping momentum, or the flipping effect. Now, you might be saying, well, but how do I know that it's really the curvature? Could it work because of just the water? Let's test it out. So, if you happen to have another glass, a tall glass, that is now not curved, so this glass is perfectly circle, but this glass is circle on the top, well, circle-ish, but on the sides here, it's pretty flat. So we have a good comparison of a flat surface of a glass versus a very curved circular surface. So let me hold up again my two arrows, and this is our comparison. So I'm gonna fill in the water until we go past the height of the arrow, and look at that. So you can see that the refraction index, the effect of light going through air into water, into air, back again, is magnifying the picture of the arrow. So if they were pretty similar in size, through the water, one looks bigger. But the flipping is a feature of the curvature of the glass. So curved glass, we see a flipping. Whoop, there we go. If it's a straight glass, there's no flipping, only enlarging. Isn't that cool? I just love that. That's amazing. I hope you enjoyed the experiment for today. That's all the stuff that we have to show you. We had two experiments with baking soda, one with lemon juice, one with vinegar, but both of them are the same chemical reaction, releasing carbon dioxide, which is the same gas that we inhale and exhale all the time. And we saw how you can create your miniature volcano thanks to Bipasha. I showed you how you can use it as an extinguisher. Fun fact, you can buy carbon dioxide extinguisher at the store. But that's a bit different because that's pure carbon dioxide. You don't create a chemical reaction there. And lastly, I showed you how you can curve light and flip an arrow going from one direction to the other by using a curved glass, which is just so fun to watch, how to flip arrows like that. You can try other drawings yourself. If you like to do these experiments, please try them at home. If you love sharing your work, please share it with us. Send us to our email, post it on our Facebook page. Show us your work in a video, in a picture. Tell us how you liked it. I hope to see you again next time. I'm Dr. Alon Eisenstein, hailing from Toronto in Canada. Stay safe, be well. Bye for now.